So this will kind of extend some of the things that Bob talked about in terms of what techniques you can use and sort of really how reliable are they. So this does provide some research-based information to persuade you and your audiences that you might come in contact with. We can skip some of this. Okay, Bob mentioned that when rainwater falls across the surface, runs across the surface, it picks up all kinds of things. And how free the water is from those contaminants determines the water quality parameters. And we have a whole host of nasty things: hydrocarbons, benzene, which is from gasoline, a fuel additive, this MTBE, heavy metals like copper, zinc, cadmium, lead, pesticides, herbicides, and then things that aren't really toxic but that cause problems when they're in too much abundance. So those include organic material, carbon, nitrogen, ammonia, things like that. So those are the things that we're concerned about. We need to make no mistake that stormwater is pollution. It's worse than pollution that's coming out of the point sources from industry now. As Bob mentioned, the primary cause of poor water quality in our streams, lakes, rivers, oceans is stormwater. This photograph I took was in mid-spring, so this was after there were several rainstorms in our area, and this is off of a parking lot, and there happened to be a bit of leaf litter that was clogging the drain inlet, and so some of the water was standing for a few minutes. And when you talk to stormwater people, they'll tell you that the first flush, right, when it's been dry for several months or several weeks and you get a rainstorm, then we get a flush of sediment and pollutants, and if we clean those, then everything should be good. But that's not really true. This is mid-spring. There have been several storms. This was a very light rain, and you can see that the whole surface of the water is covered with antifreeze, grease, oils, hydrocarbons, and all kinds of things there. So that's not necessarily the case. It is true that the first flush does often have a heavier load of pollutants, but it depends on how much sediment is on the surface. If there's a lot of sediment, that may not actually wash into the catch basins and the streams until there's a very heavy rain, which may be a couple of weeks out. And so we have to be a little bit careful about some of these rules of thumb. Nevertheless, we typically select a water quality storm. Usually it's the 2-year, 24-hour storm. Some agencies say it's the first inch of water that falls across the whole site. Collect that water and treat it, and you'll take care of 80% of the pollution problem that occurs on the sites. This was sort of a daunting table. I took out all of the fields that we didn't want to look at, but I did want to leave in enough of these to sort of demonstrate where these pollutants come from based on the kind of land uses that you encounter. And so, of course, we would think that auto retailers, or recyclers, I should say, would contribute lots of contaminants to stormwater. But residential lawns also produce a huge load of nitrogen and phosphorus that damage our environment. Even rooftops, in some cases, provide large quantities of lead and copper and zinc. The thing to note here is at the very bottom line, there's water quality standards. These are standards established by the Environmental Protection Agency and originally for effluent discharge from sewage treatment plants. So you see under this first category, total suspended solids, that the standard is 30. That's what the sewage treatment plant has to comply with. And yet if you look up the list there, you'll see that the stormwater has many times greater than that. So this would be illegal for your sewage treatment plant to discharge, and yet it's running directly into the streams and the lakes in the area. Similarly, there are recreation water quality standards established by the EPA for either swimming or for fishing and boating. And we can see as we go down that line that the the kinds of contaminants in stormwater greatly exceed the EPA standards. Okay, so we've dealt with water in several ways. Bob showed us a couple of them, and I'll show a couple others. The traditional method is to really not deal with water quality at all, just concern ourselves with flooding potential. And in this case, we capture stormwater off of parking lots and buildings, and we simply temporarily hold it. So we pause the runoff, and then we allow the rate of runoff to continue after the storm stops. And so in this way, we hoped that we could avoid that down channel cutting that Bob showed you. And so that's sort of the minimum standard you find. This is one of those detention basins newly constructed in my hometown. So we're way behind the mark in terms of what's available. This is a much better solution. This is a freshwater marsh land, and on the left side of the image there's a pool. It's a sedimentation basin. So the stormwater comes in laden with sediment. It stalls there for a moment. The sediment drops out, taking with it a lot of heavy metals and things like that. Then the water is distributed evenly across this marsh and flows uniformly through this vegetation. And as it goes through the leaf litter and the stems, actually bacteria that's living on those surfaces pull off phosphorus and nitrogen and other contaminants. This one was installed in a suburban residential development in North Carolina, and it was primarily because the amount of phosphorus and nitrogen, particularly, that were entering the tidal creek caused shellfish closures for most of the year. And after this was installed, then those shellfish beds recovered, and they became an economic resource again for the community. In addition, you can see back at this one, there's very little contribution to the community from this except for the flooding prevention, right? It's ugly, it's hidden away, there's very little habitat value, and not unsafe. And it's unsafe, yeah. And they've warned us about that, right? We fenced this off, don't come near this. So it isn't a very helpful contributor to the local economy. Whereas this incidentally provides recreation pathways and picnic shelters and educational boardwalks across the wetland. It provides excellent wildlife habitat. So you're getting multiple benefits. And I'll keep stressing this. This is the key to getting the acceptance of stormwater measures in your communities. If you simply rail about stormwater pollution and all of that, you get a lot of pushback from the business community about the economic impact of providing these new facilities, that it's really a tax, it's an unfunded mandate, so on. You've heard all of those arguments. But if you can attach these multiple use arguments, then you widen your constituency. So those people who care about more than the pollution aspect, but that care about the recreation aspect, they're willing to throw their weight behind a project and provide the political will and convince the city councils to fund projects. This is a slightly different kind. It looks sort of similar, but this is an infiltration basin. Okay, thanks. Infiltration basins are really reservoirs that are filled with rock. So there's a 4-foot deep layer of stone, crushed rock, below this park. And these plants are sort of water tolerant plants. When it rains, the water goes directly into that gravel substrate and is held there until it infiltrates into the groundwater supply. If the rain is really heavy and that rock reservoir fills with water, then there's temporary ponding on the surface. Once the rain stops, eventually then that water infiltrates down. With a really torrential rain, the 100-year storm or something, then you see in the foreground there's a drain inlet that takes the overflow to protect the community from flooding. So in this case, we have flood protection, water quality improvements, as well as the center point for a community park in a residential neighborhood. This is High Point in Seattle. And this is how these work. This one's slightly different. It has really layers of sandy loam soil over gravel base. In this case, there's a flooded portion at the bottom that always has water in it. And not to get too technical, but the upper portion of this basin is oxygen rich. And so in this case, then we have conversion of organic material to ammonia. But conversion of ammonia to nitrates and then nitrates to nitrogen gas, that requires an anaerobic situation, an oxygen depleted environment. So the top half is oxygen rich, the bottom half is oxygen depleted, so that we get a full range of contaminants removed from the system. But they're very sort of simple systems, 3 to 4 feet deep, and they require about 5 to 8% of the catchment area in the development district. And here are a couple of case studies. I'm running out of time, so we'll go quickly, but here's a parking lot at a university. Again, this one is really simple. It's just a pit that was dug and then filled with sandy soil. And then the trick is here that we have a very high infiltration rate below the basin. So the water goes through and into the groundwater. To make these things work, you have to keep the heavy equipment out of the pit when you're digging it, or you ruin the infiltration rate. You have to dig with certain kind of shovels in order to keep the infiltration rate high. These things actually work. We have research data showing good performance. This one, however, if you look down here where it says nitrate and nitrite, it says -5. That means that the nitrates were increased in this situation, and that's because of the absence of this flooded sub-basin. So you probably do need a environmental engineer and a landscape architect to help you develop these in communities. But they're really important because, partly because we need to, in rural towns particularly, older cities, we have stormwater sewers that mix with sanitary sewers. So when we have heavy rainstorms, the capacity of the sewage treatment plant is exceeded because of this huge flush of stormwater. In that case, untreated sewage flows out of the sewage treatment plant and into the streams and rivers. So, thank you. So that's really a horrible idea. And we're finding cities like Philadelphia spending $4 billion over the next 10 years to remove their downspouts from all the buildings because their stormwater system is connected to their sewer system. And that's a bargain compared to increasing the capacity of the sewage treatment plants to treat that water. And so we find these as sort of landscape amenities. Here's a parkway and a parking lot and a school in Oregon, street side. This is essentially the same thing, but just in a linear fashion. And that these things can also be beautiful. They can have great aesthetics. This is a leftover piece from a road alignment project. And the plants, of course, beautify the area too. You can see the terrific root system. Again, multiple benefits, habitat, recreation, stormwater can be combined and begin to create landscapes like this one. On your jump drive, there are a number of supplements that you can look at in more detail if you have more questions about the technical aspects of the system. Thank you.
All right. Thanks, Gary. So next we have Jerry Goodspeed to talk about native plants for sustainable landscaping. And you know, as both Gary and I pointed out, you know, bioretention and using plants are a very effective mechanism for water treatment and sustainable water resources. So let's welcome Jerry Goodspeed.